Hello and welcome back to the Clean Sailors podcast. I'm your host, Holly, founder of Clean Sailors. Now let's talk about sea, marine, sailing, and keeping it clean. It's easy to think that all fish belong in the sea, but not all fish belong in all parts of the sea, threatening local ecosystems, disrupting and at times eradicating other species entirely, and even disrupting our economies. Our boats, large and small, can transport different creatures around our waters, and at times, across whole oceans. In this episode, we'll be looking at how species spread across our planet, just what this costs us, and how the warming of our oceans is likely to make this even more pronounced. Joining me is marine spatial ecologist and all-round conservation superstar, Dr. Alexandra Davies. She is a postdoctoral fellow at the University of Alberta and a true expert on this very matter. Tell me a little bit about you, your main areas of interest and expertise.
I think of myself as just an ecologist, which just means that I study ecosystems. And so I like it because it allows you to, instead of focusing on one particular species or one particular phenomenon, you look at the system as a whole and think about how it works together. And so I end up looking at a lot of species as kind of my focal for study areas, but I also get to look at how those species interact with each other. I get to look at how species interact with the habitat, which is kind of my first love, is just looking at different types of habitat and landscapes, especially in the ocean. And then you can also think about how humans interact with all those different things as well. And so it's a really holistic way to look at something, especially in marine science, kind of conversely to maybe a more traditional fisheries approach where you have one focal species and all of your effort goes into understanding that species. So I get to look at the big picture, which is really fun for me.
Ultimately, we are one, right? Now, I think we're getting it more broadly, that we are just one huge interconnected system, whether it's talking about the ecology of our own bodies and how interconnected different areas of our own cells are versus us within a much wider ecosystem, which is ultimately the planet. And then ultimately beyond that, dare I say it, the universe. Like, it's in some ways, listening to you talk about it, it's quite odd that we have been in some ways quite so siloed, whether it's in science or just our general thinking, that one thing is separate from another, where to your point, everything is so interconnected.
Yeah, especially for invasive species, which I think is really important. A lot of times in kind of the conservation realm, we think about what do we do to conserve a species? And so that's all very proactive. What do we do to save something? And a lot of what I do is thinking about conservation in a broader term. And that includes, if you want to conserve something, you also have to think about managing different species in a different way. And so maybe removing some things. And so trying to really think about invasive species as part of a conservation plan and not two separate entities.
It's incredibly interesting, right? Because as you said, we're so obsessed now with conserving and restoring, when actually in order to get there are things that actually shouldn't be there. It's happened in some cases relatively quickly, but let's talk from the very beginning. So in terms of invasive species, these are obviously species that shouldn't be where they are.
Yeah, so invasive species, I think, have gone through a lot of different definitions. There's tons of different labels that people give them. So non-native, non-indigenous, alien, invasive. So they all are kind of different grades of a similar theme. And so one of the things that we think about with an invasive species is it an established population? And so Florida is kind of like a really classic example where you've got a lot of random one of an individual species, but it's not a population. And so for it to be invasive, you have to have an established population. But one of the things we also think about now is it having a negative effect on the native ecosystem? And so in a lot of cases, you get these introduced or non-native species and they don't do a thing. They're just there. They're really low numbers. They're not negatively interacting with native populations. And that tends to be fine. You get those, we end up having them being kind of like naturalized species. But the invasive species, the big thing is that it's altering the native ecosystem in a negative way. And negative way can be kind of a loose term as well, because often we think of it in terms of things that we care about, And so giving very large scale, environments are always changing, but what makes these things that we need to manage is the fact that they're starting to affect resources or historical things that we as humans care about.
And I guess in terms of things that we care about, that would be food sources, recreational activities. Do we have enough space? Do we have enough room? Can we sell a property? Or is it something that's going to be quite damaging and detrimental and knock the price off things? Because appreciating obviously invasive species, and we'll talk marine because obviously this is so important for our sailing and yachties and seafaring environments and listeners. But these occur everywhere, right? I mean, you've got Japanese knotweed growing in gardens, and actually in places in the UK, for example, we've got these beautiful green parakeet birds flying around London, which is so pretty, but really shouldn't be there because they terrorize everything. And I'm guessing like the concept of invasive species, or I should say, regardless of in some ways the definition at this point, but I imagine over time, the prevalence of invasive species and different types of invasive species has just gone up and up and up, right? In terms of how globalized we are, whether it's through shipping and, moving food around the world. I'm likely going to get stuff caught in a bunch of bananas and whatever else that we're moving from country to country. Are we seeing that there has just been this colossal spread over the last, say, 50, 100 plus years of these species turning up in places which are actually quite unusual?
And if you think about, if we focus on marine, I think the kind of the exponential growth of like shipping and things like that is kind of doing exactly what you're talking about before when we weren't moving as humans, because one of the main ways invasive species can spread is hitching rides on humans and our boats, our vehicles, things like that. And so the more we move, the higher the chances that we're going to be taking some species with us, which, like you said, is one of the reasons why we do lots of things like washing our boats off, checking your tires when you drive across countries, not taking, when people cross borders, they're very strict about the types of fruits and vegetables that you can bring with you, things like that. But yeah, the more humans move, the higher chance we have. And it's like you said, kind of an exponential growth curve. As we move more, the number of invasive species really rose. Yeah.
How bad is it? I mean, appreciating you've got a couple of species that you're particularly interested at the moment in terms of studying. But when we talk about invasive species, pretty much all being detrimental, right, to the ecosystem in which they're settling in, how bad are we talking?
One of the statistics we always talk about is just money. So if we think about what this is costing us, the management of invasive species, repairing damage and stuff like that, it's trillions of dollars globally. Trillions of dollars globally are spent in removing invasive species, fixing things, anti-fouling, all that stuff, just science, all that type of stuff. So it's a huge, huge, huge sink for money. And so if you're just a numbers person, like that is one thing. But if you think more thinking about the ecosystems, it's depending on where you're at, it's changing things. It's causing species extinctions to go up. And so a lot of times why invasive species are bad is because they can just outcompete native species. And so you get this non-native species in, it's released from a lot of the pressures of its native habitat. Maybe it doesn't have any parasites or blights or things like that. It doesn't have any natural predators. And so it just thrives. And oftentimes that leads to it outcompeting native species or eating the native species, moving them out of space. And then you get these native species that we care about and they become endangered, or you can even get local extirpations, which is where you've got like a small habitat patch and that species is completely gone from that habitat. So that's one of the things I care about is the change in species composition. The other thing that an invasive species can do is they can actually change the habitat. And so if you think about like things like shellfish, they're big habitat builders. And so they can change the way that our shorelines look. One of the species that I study is the European green crab, and those tend to destroy seagrass beds. And so seagrass beds are really, really important for a lot of different things. They're nursery grounds, they help clean our water. And so by removing those grasses, we then have just these mud flats, which is a completely different ecosystem. And so those are kind of the main ways that we see or that we try to talk about, especially when we're talking to the public, because those are very visceral things. You can say, well, you can see you used to have a beautiful seagrass bed here. Now you just have mud, or it's something like that. You try to evoke that kind of imagery so that people understand why invasive species can be detrimental.
And I guess to your point, normally they are exceptionally good at surviving, right? And often that means they can be poisonous, they can be prickly, they can be the natural hunters of species. And I guess your point is it's the disruption of not just a the status quo, right? Because that's not always bad, but it's more the loss of actually a fundamental system that's been working for sometimes, fair enough, changing, but it's been working as dynamism for thousands, sometimes millions of years, right? I mean, these are ecosystems that have been running our planet and our fresh air and our water and our weather and everything else. And even your point about seagrasses, I mean, there's probably, I can't actually think of another single species of plant, let's say, particularly within the marine environment, that has such a positive impact on carbon capture, like you said, as being the nursery ground of so many species, which in turn supports the whole global marine food chain, right? Which then supports our food chain.
Exactly. Yeah. And one of the examples from the studies the species that I study, so the invasive lionfish, so they're native in the Indo-Pacific in areas like Australia, Indonesia, and in their native ranges, they're really low densities. So you don't find a lot of them. They're really cool to look at. And so they've become a popular aquarium fish because they're just beautiful. They've got these lovely stripes. They've got these iridescent kind of finishes on their fins, and they're just really frilly and they're just beautiful. But they're kind of, they've been described as a perfect invader, because when in the non-native range, so areas like Florida, the Caribbean, all the way down into South America, Gulf of Mexico, not very many things eat them, if at all. They tend to have fewer parasites than they do in their native range and of native species. And then they're very indiscriminate about what they eat. And so they'll eat parrotfishes, which are really good for reef health, and they're also a big commercial species. They'll eat juvenile grouper, which are another big commercial species. And then it kind of removes that like competition that they would have when the grouper get bigger. And so they're kind of that, hey, we're thriving in this area, nothing's bothering us. There have been some instances of ulcers on them, but kind of outside of being sick, they just do really well. They just kind of hang out on the reef, nothing eats them, they eat whatever they want. And so, that's kind of one of those like perfect examples of something that's removed from all its pressures and then just basically explodes as a population.
I think the lionfish is the one thing that have since learning about them, have been obviously trying to prep for speaking to someone as smart as you on these kind of topics. One kind of species that is just fascinating. I mean, to look at them, and we'll make sure we share some pictures and stuff with this podcast, because they're extraordinary. They've got these beautiful spines. They're incredibly colourful and bright, literally sort of orange and browns. And they look kind of lazy. They look super chill, right? I mean, if their faces almost look just so human, to the extent that that's your resting face entirely. That's your chilling face. And they move quite slowly. I mean, they're not shark-like in their approach or their kind of streamlinedness. They
hover a lot. Yeah, they hover.
And they're the kind of species that you almost believe to be indicative of a healthy environment, right? You see them in the aquariums and you see the color, you see that kind of, I don't know, they just look really old and established and fascinating. But to your point, I mean, these fish have actually made their way over to across the Atlantic, and they're actually now in the Mediterranean, apparently, via the Suez Canal. So talking about them being, I say, your patch, like on the other side of you, Canada and the US, in the Indo-Pacific kind of region, they are making their way now globally, right? I mean, this is a species that has been too good at being invasive.
Yeah, it really is. And one of the reasons it's interesting, because they've been found in so many different environments. You can find them in really low salinity waters, and people have actually even found them up rivers. You can find them at incredible depths, up to like 300 meters, which is way beyond what most divers can get to. You find them on seagrass beds, you find them on reefs, you find them on natural structures, you find them sitting on a patch of sand with nothing else around them. And so they're just kind of happy everywhere, which is just, so it's like, okay, you can't just focus on coral reefs. They'll always be there. No, they will not. They will be on a random crate that somebody dropped in the water, and that is where they live. They'll be in a river. And so they're an extraordinarily resilient species, which is, not great for an invasive species, but great for them as individuals.
Sure. And how did they get there? And I mean, everywhere is more the question, because every species comes from somewhere, right? So where were they native? Where was home for the lionfish?
They're native in Australia and Indonesia. And as I said before, because they're so beautiful, they were traded very heavily as an aquarium species. So there's not an exact like pinpoint as to where these invasive species came from. And there's a couple of different thoughts where kind of the classic, like, I got this fish and it ate everything in my aquarium, so I dumped it into the ocean. And so there are probably a lot of occurrences of that, enough to where the species could then establish. There's also some evidence that like a freighter ship that was carrying some of these lost some of them in a big storm and basically kind of just like dumped a bunch of them into the ocean. And so the only real knowledge is that it's almost, 99% guaranteed it's humans' fault that they're there. Otherwise, there's no way that they would have made it naturally over to the coast of Florida from Australia. That's not going to happen naturally. And so it's definitely one of the examples of like a human introduction. So,
and I'm just going to test you on that, Alex, because I feel as in they wouldn't have made that journey. It's an exceptional journey, right? Any sailor who's done that will know just how big a piece of water we're talking about. They would not have made that because it's such a long way to go and there's so much depth and there's so much danger, I guess. Or is it also to do with sea temperatures? Because arguably, do you feel that because of sea temperatures rising, native species then potentially have the capacity to be spreading further because their temperate, natural, happy place and zone in terms of, whether it's the food that they can eat, whether it's the warmth that they can survive in, whether it's the salinity, to your point, if that changes in our global waters, then that gives them potentially a lot more license to spread a lot more further over time. I guess to your point, it's maybe the time at which the lionfish, or the time in which the lionfish was spread, is very unnatural. But perhaps over talking, a couple of 100 years, can we expect to see actual natural migratory patterns of different species because of our climate changing?
Yeah, so there's kind of two different parts to that. And so one is just like the concept. So if you're thinking about basically physical barriers to moving, and so that could be something like a mountain range or a huge, basically, quote, empty ocean. And so there's a lot of species that just won't be able to cross those barriers kind of regardless, even if their temperature is higher or something like that. It's just too big of a physical barrier for them to do it naturally on their own. And so that's where when we see these anthropogenic introductions, it's like, okay, I physically picked up and moved this species in a way that it never will ever be able to move on its own. It will never cross that natural barrier. And so that's something that we kind of see with like a lot of ballast water introductions. Like those larvae will not physically get from the ocean to the Great Lakes on their own. We did that. But to your point about kind of climate change and changing temperatures and changing environments, that's what we call like a range expansion. And so for lionfish especially, so they are limited by sea surface temperatures. And so as our sea surface temperatures start getting warmer and warmer and warmer closer to the poles, if that's their limiting factor, they will then start moving outside of the range that they currently are. And that can apply to a lot of different things. And so for the ocean, a lot of what we see is we get those tropical and warmer species just moving further and further up because they now can survive in what we had like colder climates. And so for lionfish specifically, during the summer, you'll get them all the way up the coast of the US, like to like places like Rhode Island and New York, but they're very seasonal there. As temperature changes, that could also change. And one of the things that we also think about for lionfish is kind of a reintroduction into the Pacific. And so again, kind of like along the coast of California up into Oregon, it's very, very cold. It's a very temperate climate. But if that climate shifts and those waters stay warmer for longer, then it becomes a suitable habitat for those species that we would never find there naturally. So there's kind of those two different parts of that invasive spread.
That's incredible. And it's an awesome explanation. Thank you. Because I think obviously we do have a huge part to play in a variety of species spreading around the world, right? But there is also this undertone of, oh crikey, what's it going to look like in a couple of years' time? Because to your point, I mean, invasive species, I was really annoyed when I heard about lionfish as an invasive species, and then you see them and you're like, oh, but why? Why these?
They're so beautiful, I know.
Exactly. But then, to your point, invasive species aren't positive, right? And it could be lionfish, or we could be seeing, jelly is spreading further because of how much warmer temperatures our waters get. And they too, jellyfish, as incredible as they are, they impact everybody. They don't, not just from a leisure perspective and swimming, but they really don't have, I guess, aside from turtles, many other predators at all in the ocean, right? So they're very controlling those kind of populations if they get out of hand is near impossible. What are some of the ways that you found or heard to be most impactful in controlling them? Because I appreciate, again, each species is different, right? So that's a tough job.
Yeah. So obviously the best way is prevention. And so that's why, especially for things like ballast water and like things like cleaning your boat bottom, there's so much effort put into that, because if you can prevent the species from ever showing up, you never give it a chance to establish. And that, for some of that, it's a little too late. There's a lot of species that have happened and now we're trying to control increase in populations, but prevention is always the best way. And you can kind of think about invasive species populations establishing in like a very sequential way. And so prevention is one. You can catch it before it happens, you're good. You've got none of the species there. If you can then have monitoring programs. So if you know that your harbor or your waterway or whatever area you're managing is likely to have invasive species, then you can monitor that. And that's, again, why we check things like ballast water. That's why we regulate what can go across borders. We know that people will likely bring these in purposefully or accidentally, and we're going to monitor that, and we're going to prevent it if that happens. And then along with monitoring, you can think, okay, well, if you're thinking about a range expansion, so for lionfish and for green crab, we know they're in areas, and because the ocean is open, we know that they're likely to move. And so, okay, my neighboring country, my neighboring state, my neighboring province, they have green crab, they have lionfish. We are now going to monitor knowing that it's likely that they will start to show up. And so if you can catch those and remove them whichever way you can when they're really, really low densities, that also kind of negates them from establishing as a population. And so that's what a lot of people are doing with these kind of really prolific species that we know are probably going to start creeping into different ranges. So you try and catch them at really low densities because that's your best chance. There's a lot of different ways, depending on the species, that you can actually do removal efforts. Things for like lionfish and green crab, it's all hand by hand. You're either trapping or you're netting, removing them by hand. Different species, you can do things like, for plants, obviously, things like herbicides are really helpful. One thing you never want to do is introduce a predator for your potential invasive species or something, introduce something else to control it. I don't think that has ever ended well for anybody. And so that's one that's off the table. Or you introduce like a snake or a bird to get at some rodent, and basically instead of going after the invasive species, which is really good at surviving, it goes after things that have never seen that type of predator before. And so I'm a little rodent, I've never seen this like thing that's hunting me, I don't know to be afraid of it, and it just devastates the populations. And so a lot of times what people will suggest or think about doing is introducing a bigger predator. And so for lionfish, it would be something like a grouper. You can't predict what's going to happen. If this species is doing a good job avoiding predation from what's already there, they're probably going to avoid predation from something else that you introduce. So it's never a good option.
I guess to your point, maybe too much intervention or the wrong kind of intervention almost makes the matters worse, right? Because we're talking about natural ecosystems. They've survived for long enough in a dynamic without us, right? So there's a fine line between how much we do get involved and introduce and try and rechange things versus how much should happen in some ways a little bit more naturally.
Yeah, so for lionfish, where we're at right now, it's mostly hand removals. And so there have been some studies that have tried to figure out if we can kind of acclimate native predators. So like you said, like a shark or even like more ray eels or a really big grouper. So Nassau grouper, kind of one of the big, almost like dog-like groupers on a lot of the reefs in the invaded range. And they will eat lionfish, despite the fact that lionfish have venomous spines. They can eat them, especially if they eat them face first, so they're not getting poked. But there are so many other things for the native species to eat that it's not necessarily worth, to be very anthropomorphizing them. It's not really worth their time to learn how to eat lionfish. They'll eat them if you spear them and feed them to them. They're like, yes, free snack. But there hasn't been a whole lot of evidence that they're learning or becoming more willing to eat lionfish. So biocontrol is one thing people think about a lot, but it's not always the answer. It is nice to think about because if we can find something, a parasite or something that can compete with them or eat them, it makes it very easy to think about. But in the case of lionfish and a lot of these things, it ends up being human removal just because messing with putting something else into the environment often ends badly.
And I guess even with, say, the reintroduction of larger adult grouper, they get eaten by us, right? I mean, these are commercial fish. Yes. So how do you say you'd have to ban commercial fishing on things like grouper in order to get the lionfish population down? I mean, I understand there were some efforts in the Caribbean, and I think certainly they're looking at doing something similar in the Med around people eating them, right? I mean, these lionfish are edible by us.
Yeah, they're quite edible.
Have you tasted one?
Yeah. So I'm typically a vegetarian, but I do make an exception for my study species. They're just like a very mild white fish. So they tend to have, lionfish are in the scorpion fish family. And so they have these like really, really big heads, which is really funny. And their fillets aren't always that big, but because they're in such high densities in a lot of these places, you can get a lot of fish like going out on a reef and spearing them. And like you said, in the Caribbean, and especially in Florida, they're doing like a lot of effort. They've got like a lionfish cookbook that you can do. They do a lot of derbies where they encourage people to go out and they can spear lionfish in like marine protected areas where they wouldn't be able to spear normally, just to get people out there. Because at this point, kind of human removal is one of the best ways is basically the only way to get rid of lionfish in the numbers that we want. And so, so things like that are really great. I know some places in the Bahamas will even offer the same amount of money per pound for lionfish that they would do for things like spiny lobster to, one, encourage fishermen to go out and get lionfish, but it also reduces the poaching of native species because things like lobster and grouper are managed very strictly. And so if you're offering people a different way to kind of continue their livelihood by helping you remove this invasive species, it helps quite a lot. So things like that are a great way to like engage the public and have them go out, especially if you're helping them like continue their livelihood as fishermen and things like that. For green crab, there's not quite the same market for them as food. I know in places on the East Coast, they've kind of made them into almost like little green crab poppers. You can kind of fry them as a whole there because they can be quite tiny, about the size of a dime or a nickel or something like that. But it's not a big crab that you can, like a Dungeness or something like that. And so that's one thing that they're thinking about. But I think for green crab, one of the things that they're trying to think about is there's a group working on creating like a bioplastic out of green crab carapace shells. And so that's, like another thing, like if we can harvest the green crab, what do we do with it? So there's a couple of ways like that. And that just encourages, I think, a lot more engagement of both industry and public if you can show them as a resource. The one thing to think about, though, is that if you are encouraging people to go out and use these invasive species as a resource, you always want to make sure it's like, we're doing this to get rid of them. We don't want this to be an established livelihood. Lionfish will never become a long-time fishery. That's not what we want. We don't want that. We don't want lionfish to be fished forever. We want them to be gone. Same with green crab. And there are places like on the East Coast of the US and Canada, they're kind of there for stay. So that could be something where it's like, we know we're not going to be able to get rid of them. We're just too far gone at this point because they've been there for over 100 years. So that might be a place where it's like, okay, we can have some sort of small industry around it. On the West Coast of Canada and the US, however, we're still in places where we don't see them. And so we're very much like, we just want to prevent spread. We want to get rid of them. And we want to figure out how to do it very efficiently because we don't want to end up like the East Coast of this continent is.
That's a really good point. If you create a market for it, then there's the potential, obviously, for it to become bigger than one can control ultimately. But it does make you think, right? And all you ultimately need, by the sounds of it, is someone to take it home as a pet on the West Coast or East Coast, vice versa, and then get bored of it one day and then go and dump it in a waterway somewhere and set it free. And then it becomes this, whole new kind of group of invasive species elsewhere. It does make you think, right? Not all fish belong in the sea. A specific area of sea. There's actually different colonies and different habitats and homes in this big, crazy ocean that we've got. It's just so fascinating. Hey, it's just such an interesting topic. One thing I did that has sort of plopped into my mind is we've obviously got this endemic plastic pollution problem, right? We've got more ocean pollution now than we've ever had in the history of ever. These are normally quite hard substances that travel for hundreds, thousands of miles, sometimes hundreds of thousands of miles in a lifetime, just circulating through ocean currents. Plastics aren't just a flat surface. I mean, there's obviously an opportunity for bacteria or viruses or whatever else to be living on and breeding on the surface of these pollutive objects that are moving through our waters. Is that an opportunity? Is that a thing that our pollution problem, our global pollution problem in our seas is actually also helping to transport stuff we really don't want it to?
Yeah, that is a good point. And again, I might get my dates and my names wrong, but when the huge tsunami happened in Japan, there was a big effort to think about what is going to happen when all of the debris from that tsunami wreckage eventually makes it to the coast of North America. And so that was a very big thing because there was the potential for kind of some of the chemicals and pollutants to come, but there was going to be also very big physical objects that theoretically could carry species, because when species find things in the open ocean, we've got those big trash piles in the open ocean, they'll live there, you form these communities. And so that was a big worry. I know this was 5 or 6 years ago when that happened. People were very worried that we were going to start getting some species coming over. And so I think in the long run, it ended up not being a problem, but it is something to think about when we've got these big circulating things of trash, even just natural debris, woody debris, things like that eventually just make their way around. And again, that's not necessarily something that's new. There's always been debris circulating, but you're right, plastics have a much longer life than something like a tree. If you've got a big plastic container, that will be there for hundreds of years, as opposed to a tree, which will decompose naturally, long before that. And so it creates these more permanent kind of floating debris microhabitats that can attract and move species in a way that they wouldn't have moved before.
And also, not just how fascinating they are, but actually why we should really care. This is not just our habitats and our ecosystems, but actually our food sources and healthy waters, right? And these are waters we sail but swim in, and that support all of our lives. So
if we can still use our waters, why do we need to care about invasive species? And it reminded me of an analogy somebody gave me about climate change, about, if you have a fever for a day or two, it's really easy for you to recover. But if kind of what our Earth is going through now is just a chronic fever, the threshold is just so much lower. And I think of invasive, a planet living with or an ecosystem living with these invasive species, is they're just kind of chronically ill. They can look good, you can still interact with them, they're doing well, but one thing will just set them over the edge, and it's just so much harder for the ecosystem to recover. And so, especially in systems where they still look healthy, they look great, you can interact with them the same way, it's hard to care about invasive species because everything looks normal. But if we're thinking about ourselves as a living entity and something that needs to be taken care of because we want it to grow old, we have to deal with these kind of chronic issues that are just, like you said, due to a lot of different things, just becoming more and more frequent in our systems. So
Alex, thank you again for joining me and for sparing the time to guide us through this incredibly complex topic. Keep up to date with your work. Can't wait to see some more solutions that you come out with and how you help to manage these lionfish and green crabs in particular. Really cool stuff.
Yeah, well, hopefully I've got a paper in review about lionfish management, so I will send it your way as soon as it goes through the final stages of publishing. So
send it over. That's awesome. Thank you for joining us, Alex.
Yeah, thank you.
You've been listening to the Clean Sailors podcast. All relevant links to the projects and people we talk to can be found with the podcast link. For all episodes or to get in touch, just visit cleansailors.com. We love to hear from you. We believe that great ideas should be shared, which is why our podcast is free to appear on. So if you've got a project, idea, or topic you think we should be discussing, get in touch. In the meantime, thank you for listening and see you for the next episode.